Hey everybody, today we'll be discussing problem number 2 in today's weekly contest 153, and I'll be making a separate video for question 3 as well, which was a very interesting DP problem. So yeah, let's get started with problem 2 first. So in this problem we are given a binary string and we want to perform at most one operation on it such that we can convert all the ones to the which are bounded by zeros into zeros, right? And then we can again select a sub array of zeros and convert all of them into ones. So we can do at most one operation, and then we have to return the maximum number of ones that can be there in S, right? And just for convenience sake, what they have said is that your string is bounded by two ones on the left and the right, so you don't have to worry about the edge cases that may arise at the ends, right? Yeah. So just to explain the problem again, yeah, let's say your string looks like this, right? So now this is a valid section of ones because it is bounded by zeros to its left and bounded by zeros to its right, right? So now you can convert all of these ones into zeros. So let's say you do that, right? And then the other operation is that we can convert a contiguous plot of zeros into ones that is surrounded by ones, basically that is surrounded by ones to all ones, right? So now this particular block of zeros, now this is all become zero, right? And it is surrounded by ones. So if it's surrounded by ones, then you can convert all of these into ones again. So this becomes like this, and let's say you have zeros over here and you have zeros over here, right? So now these three ones, and you perform one operation over here, and now these four ones, right? So total number of ones in this array, I mean in this string, is how many ever are there in this particular substring. Like this is your answer basically, assuming that everything else is zero on the left and on the right, right? So one crucial thing to notice over here is that is basically this: you will have a current block of zeros and you will have a previous block of zeros. By block I mean that this particular block is like bounded by ones because it has ones over here, like, right? And this current block is like again bounded by ones. It has ones to its left and to its right. So this is the current block, right? So if you're standing over here and if you know the previous block's index, right, then you can calculate this index pretty easily. So this length you can calculate using, like, if you're standing over here, let's say this is I and this is previous block's starting index. This is previous block dot first, this is previous block dot second means that it's the ending index, right? So and similarly current block will have its first and second. So then length of this block would become I minus pb dot f plus 1, right? And then you have to also append, like you have to also get the remaining active sections. Active section means the remaining number of ones, right? So you have to basically say how many number of ones over here, right? Basically to the left of the previous block starting index, and then the number of ones over here is to the right of the current block's ending index, right? Number of ones over here. So that's it. This is prefix p and this is suffix s. So now you'll also add p plus s over here, right? So this is one possible candidate answer, right? And candidate answer because this current block ends over here. So like this, there's a change from 0 to 1 over here, and previous block will derive it from the current block. So you'll just do answer equals to max of answer, comma, this particular expression. P and S will calculate. It's very easy to calculate. You can do it using prefix sums, like how many number of ones end at this index, that you can pretty easily calculate, right? And also one edge case is that what if we don't want to do this operation, because this is like at most one thread, so you can even do zero operations. In that case, if you do zero operations and its answer is just the number of ones in the entire string, right? Because yeah, that's what the question demands. So you will initialize your answer with this particular variable, number of ones in the entire string, and then you'll basically do this calculation. Okay, so um, let's look into the code. That's what I'm kind of doing over here. I'm just initializing the answer, and then I took my blocks, previous block and current block. Previous block is -1 and -1, and then I just augmented 2 ones on this s, right? And then what I'm doing is I'm calculating the prefix sums and the suffix sums, right? So I'm starting from 1, right? So if you have one augmented over here, you don't have to count the augmented blocks, and then your string s over here, and then you have 1 augmented over here. So this is my 0 index, this is my 1 index, right? So I'm starting from 1 and I'm going till n-1. So n is the total length. So this is your n-1th index, this is your n-2th index. So yeah, I'm going basically to n-2 because it's like saying less than n-1. So yeah, that's what I'm doing. I'm calculating the prefix sum, and then if my n is greater than or equal to 2, so I also want to say how many ones are till n-1, right? Because it might be useful. So it will just be derived from n-2. So because we don't want to count the 1 over here, right? We don't want to count it as it said in the question. The augmented one do not contribute to the final count. Similarly, do it for the suffix, and then yeah, just do this logic. So let's say if s of I is not s of I plus 1, right? So if either you're going from 0 to 1 or you're going from 1 to 0, right? So if that is the case, and if s of I is 1, so basically if you are going from 1 to 0, right, as we saw over here, like you're going from 1 to 0 over here, so that means your current block is just starting, right? So you can just say my current block dot first starts from I plus 1. So current block is basically the block of zeros, right? So let's say this one, this guy, or it may be this guy as well. So yeah, this is your I plus 1, I think, yeah. So current block is I plus 1, and else if it's s of I is 0, that means if you're going from 0 to 1, as in this case, right? So if I write a string over here, you're going from 0 to 1, that means your current block has ended. This block has just ended over here, right? So your current block dot second is I. That means your ending index is I. And then you check if your previous block's first, that means if your previous block starting index was initialized. So basically, let's say a string looks like this, and there are only ones, and it ends over here. So then there is no previous block over here, right? Previous block was initialized to -1, -1. So then you cannot do anything. You cannot do that at most one trade operation. So that's the reason that of this if check, and then you just do the expression that we wrote. So it's like cb dot second is basically this guy, right? I minus your pb dot first is your previous block's first index, which is this guy, right? This +1 plus 2 for the length consideration, and plus the prefix up till here, and then the suffix till here, right? So there is one possible candidate, and then you also make your previous block equals to current block. So since coming to this example, so this is your current block, right? This much is your current block. But since you're moving forward, your previous block would like point to the current block, and current block would be, let's say there's a 0 over here. So then this would become your current block in the future, right? And notice that we're only calculating the current block whenever we have these changes, right? So then yeah, the flow basically continues. Yeah, so there I think that's it. You just written the answer. Yeah. Thank you guys for watching, and if you have any doubts, please feel free to comment. Question 3 solution will be up soon. Thank you.